Have you ever really, truly thought about the sun? I mean, we see it every day, right? It wakes us up, it warms our skin, it makes our plants grow. But this giant, blazing ball of gas hanging out in our sky is so much more than just a convenient nightlight alternative. It's the heart of our solar system, the ultimate powerhouse, and the reason we're all here. So today, let's take a journey, 93 million miles away, to get to know our star a little better. First off, let's get the basics straight. The sun is a star. Not a special kind of star, really, just our star. It's a yellow dwarf, which sounds a bit small, but don't let the name fool you. The sun is so enormous that you could fit 1.3 million Earths inside it. Imagine that. It accounts for over 99.8% of the total mass of our entire solar system. Everything else, Sol, the planets, moons, asteroids, and comets is just cosmic dust in comparison. So, what's it made of? It's not a solid ball of rock like Earth. The sun is almost entirely made of hydrogen and helium, the two lightest and most abundant elements in the universe. It's a gigantic ball of super-hot, electrically charged gas called plasma, and at its core, something incredible is happening. The temperature there reaches a mind-boggling 27 million degrees Fahrenheit, or 15 million degrees Celsius. The pressure is so immense that hydrogen atoms are being squeezed together to form helium. This process is called nuclear fusion. Every single second, the sun converts about 600 million tons of hydrogen into helium. But here's the crazy part. In that process, about 4 million tons of matter are converted directly into energy. This is the energy described by Einstein's famous equation, E equals mc squared. This energy travels from the core, taking hundreds of thousands of years to reach the surface, and then radiates out into space in all directions as light and heat. And a tiny, tiny fraction of that energy is what reaches Earth, making life possible. The light you see from the sun isn't instantaneous. Since it's 93 million miles away, it takes about 8 minutes and 20 seconds for its light to travel to Earth. So, when you look at the sun, and please, don't stare directly at it. You're actually seeing it as it was over 8 minutes ago. You're literally looking into the past. The sun isn't a calm, steady ball of fire either. Its surface is a chaotic, bubbling cauldron of plasma. You've probably seen pictures of solar flares, these massive, brilliant eruptions that burst from the surface. These can release as much energy as billions of hydrogen bombs all at once. When these eruptions are aimed at Earth, they can cause beautiful auroras, like the northern and southern lights. But they can also be disruptive, potentially messing with our satellites, power grids, and communication systems. Then there are sunspots. These are cooler, darker patches on the sun's surface. Cooler is a relative term, of course. They're still incredibly hot, around 6,500 degrees Fahrenheit. Sunspots are caused by intense magnetic activity, and they come and go in a cycle that lasts about 11 years. We're currently in what scientists call solar cycle 25, which is expected to peak around 2025, meaning we can expect more solar flares and auroral activity. The sun also has an atmosphere, which is wild to think about. It has several layers, but the outermost part is called the corona. You can only see it from Earth during a total solar eclipse. It looks like a beautiful, ghostly halo around the blacked-out sun. One of the biggest mysteries about the sun is that the corona is hundreds of times hotter than the surface below it. It just doesn't seem to make sense. But that's the universe for you. So we know the sun gives us light and heat, but its influence is so much more profound. The sun's gravity is what holds our solar system together. It keeps Earth and all the other planets in their orbits, preventing them from just flying off into the cold, dark emptiness of interstellar space. Without the sun's gravitational pull, there would be no solar system. It also drives our planet's climate and weather. The uneven heating of the Earth's surface by the sun creates winds, ocean currents, and the water cycle. Every storm, every breeze, every raindrop can be traced back to the energy sent to us by our star. Photosynthesis, the process plants use to create their food, is entirely dependent on sunlight. This forms the base of almost every food chain on Earth. So that apple you ate, it's basically a little package of stored solar energy. In a very real sense, we are all powered by the sun. But our sun won't be around forever. Like all stars, it has a life cycle. Right now, it's about 4.6 billion years old, roughly middle-aged. It's been happily fusing hydrogen for billions of years, and will continue to do so for about another 5 billion years. But eventually, the hydrogen fuel in its core will start to run out. When that happens, the sun will begin to change dramatically. It will start fusing helium and other elements, causing it to swell up into a red giant. It will become so large that it will swallow Mercury, Venus, and very possibly Earth. Our planet will be vaporized. It's a terrifying thought, but don't worry, it's not something we need to pack our bags for anytime soon. We have a good 5 billion years to figure that one out. After its red giant phase, the sun will shed its outer layers, creating a beautiful glowing cloud of gas called a planetary nebula. And at the center, all that will be left is its tiny, hot, superdense core, a white dwarf. It will be about the size of Earth, but incredibly heavy. This white dwarf will no longer produce new heat, so it will slowly cool down over trillions of years, eventually becoming a cold, dark black dwarf, a final stellar remnant drifting through the cosmos. It's a pretty epic story, isn't it? From a cloud of gas and dust to a life-giving star, a destructive red giant, and finally, a quiet, stellar corpse. Studying the sun isn't just about understanding a distant object. It's about understanding our own home, our past, and our ultimate future. Every day, missions from NASA and other space agencies are watching the sun, learning more about its behavior and its secrets. The Parker Solar Probe is actually flying through the sun's corona, touching the sun for the first time in history, gathering data that will help us predict space weather and solve mysteries like the coronal heating problem. You're feeling the energy from a nuclear furnace 93 million miles away. You being touched by a star that has nurtured life on our planet for billions of years and holds the entire solar system in its gravitational embrace. It's not just a light in the sky. It's our cosmic anchor, our life source, and an endless source of wonder. Thanks for joining me on this journey to the heart of our solar system. If you enjoyed this cosmic exploration, don't forget to hit that like button. Subscribe for more adventures through science. See you next time.